Yes, welcome to another math session. In this session, we'll be looking at trigonometry. So we'll start with a question on trig functions. So for question 5 here, we can see we have two functions here. So the first function that we have is f of x. We can see f of x. So f of x is given by the f here. Okay, let me highlight. Okay, so this f of x is given by this function here, right? So this is the function of f, and then g is given by this function here, right? So we have two functions here. We have f and we have g. Okay, it's very important to take note. Okay, so we are told 5.1 that we need to write down the period of g. So we can see here we are given what? We are given f of x equals to negative 1 over 2 cos x, and then g of x equals to sine x plus 30, and we're given the interval here. So we can quickly write the period of g, because we can see that this is g is this function here. So the period of g, we can quickly see here, it's 360. How do we see it's 360? We look at this x here. So if we don't multiply anything with x, right, the period will be 360. So if x was multiplied by 2, it won't be 360, it will be 360 divided by 2, which is what? Which is 180. So in this case, we don't multiply our x is on its own here. So the period has to be 360. Okay, so let me change the colors. So for question 1, which in this case is question 5. So 5.1, the period of what? Of g is what? Is the period of g is 360 degrees. Okay, and then 5.2, what's the amplitude of f? So f, we can see, is this one here. Okay, so f is this function here. So we need to find the amplitude of f. So when we have this equation here, we need to look at the coefficient of this function. So we look at cos x, right? So we have cos x. So what is the coefficient of cos x? We can see is negative half. So you need to take note when you determine the amplitude. So always amplitude has to always be positive, right? So the amplitude always has to be positive. So in even if we have what? Negative half here, it will be what? It will be positive half. So our amplitude will be positive half. Okay. And then 5.3, they ask us to determine the value of the function f 180. So the f of 180 minus the f of minus the g of 180. So we can see that the f is the one highlighted in yellow here, and then the g is the one highlighted in red here. So we look at 180. Where is our 180? Our 180 is somewhere here, right? So how can we find the difference between F180 minus G180, right? So we need to go back to the equations that they gave us. So our F, we're given F as what? f is equal to negative half cos x. So we are looking for f 180 degrees minus g 180 degrees. So we can simply substitute on our equations here. So here, when we substitute 180, we'll be having negative half cos 180 minus sine 180 plus 30. Okay, sine 180 plus 30. Okay, so how do we figure that out? So we can just simply use our calculator. So we can use our calculator, the negative half times cos 180 minus sine 30. Okay, and then we find our answer. So our answer is what? Our answer is 1. So 1 is our answer. Okay, so 5.4. So for 5.4, we have 4.1. Okay, 5.4.1. Okay, so 5.4.1, they want us to find the f x minus 10 equals to g x minus 10. So we want to see where these two graphs are important are equal. So where f is equals to g, right? So but we must be careful because here the graph is shifting to the right with 10 degrees, right? It's also shifting to the right here with 10 degrees. So, but from what we are given, we can see that these two functions, the f and g, are equal at 130.9. So they are equal here at 130.9. So, but just because the function is shifting to the right, so both functions are shifting to the right. So instead of us having our coordinate of x as 130.9, so if it shifts to the right, it will be what? It will be the x value will be 130.9. Then we need to add 10 degrees. Why? Because we're shifting to the right. So it will be 140.9, right? So 140.9 is the value of x in this case. Okay. So moving forward to the next one. Okay, so for 5.4.2, okay, 5.4.2, we have what? We have the square root of 3 sine x plus cos x greater and or equal to 1. Okay, so what we need to do here in order for us to solve for x, we need to reduce, because we have the sine x and cos x, so it's two functions. We have to reduce these two functions into one function so that we can be able to solve for x. So how can we reduce this into one function? Okay, we must think about our compound angles, right? So when we think about compound angles, how can we write these in terms of the compound angles? Okay, So what we can do here, we can decide to divide by 2 everywhere. So here we also divide by 2, and then here we divide by 2. So we can do this, it won't change anything. Okay, so since we have square root of 3 divided by 2 here, and then half here, we can see that these are what are special angles, right? These are special angles. So with our calculator, we can see which trig function equals to square root of 3 divided by 2. So we want to see which trig function and its angle equals to square root of 3 divided by 2. Okay, let's check cos. Let's check cos. We'll start with cos 30. Okay, we can see from our special angles, we know that cos 30 is square root of 3 divided by 2. So instead of writing square root of 3 divided by 2, we can just say cos 30 sine x. And then this half, the half is also a special angle. So if it's a special angle, let's see the sine. What about sine 30? Okay, sine 30 will give us half. Okay, so instead of writing half, we can just say sine 30 degrees cos x greater or equal to a half. Okay, so now that we have our compound angle here, we can reduce it. So this is the same as sine x plus 30. Okay, so is greater than or equal to half. Okay, so for us to solve for x, okay, we can equate sine x plus 30 equals to half, and then solve our angles. Okay, so with our calculator we can go, okay, shift sine half. So shift sine half. So 1 over 2 is half. So we see we have what? We have 30. We're trying to solve for x, remember? So we have 30. So it means that the first value for x will be 30 minus 30, which is what? Which is 0. Okay? So we can see that the first value for x is 0 degrees. Okay? Okay. So let's check where our sign, because we can see here sign is positive. Where else in our cast sign is positive? So we can quickly draw our cast. Okay, so we can see that sign is also positive where? At the second quadrant, okay? At the second quadrant. So this will be what? The next one will be 90 plus our angle here. Okay, so for us to get the next value for x will be 90 plus 30, which is 120 degrees. Okay, so it means that where sine x, right? So where sine x is greater or equal to a half, so it's between here. So if we look back here at the function here, so it's between somewhere here at 0 here and somewhere here, which we calculated as 120. So it's in between here, our value for x. So our x value will be 0 x 120. So for us, for the sign um, x plus 30 to be greater or equal to half, you can see this is half here. This is half. So for it to be greater than half, so it must be somewhere here, greater or equal to half. So it's somewhere here. So in between the interval of 0 and 120. Okay, so we're done with this question. So moving forward, okay, let me move this down. Okay, so for question 6, we are given a diagram and a coordinate of p. So we're given p equals to -5 is to 12. And then we're also told that t lies on the positive x-axis. So we're given t, this is t here. And we're also given that POT, so POT, this angle here, right? It's what? It's theta, okay? So they ask us, without using a calculator, we need to determine the value of tan x, okay? So the first thing that we need to do, right? So if you are given a line like this, right, with a coordinate here, so what you need to do is to make sure that you extend a line to the x-axis. From this point here, you need to extend a line always to the x-axis, right? Not extend a line to the y-axis. You extend the line to the x-axis and then you label your coordinates. That's the first thing you need to do. Okay. So for x, right, is -5. So it means here has to be what? -5. And then for y is what? Is 12. So it means here it has to be what? It has to be 12. Okay. So now it's easy for us to calculate or determine the value of our trig functions. Okay, so for the first one that were asked, okay, 6.1. So 6.1.1, we are asked to determine the value of tan theta. So for tan theta, we know is what? Is opposite over adjacent, right? So opposite over adjacent. So what is our opposite? Our opposite is y. Okay, this is our adjacent of which is x. So our y value here is what? Is 12. And then our x value is what? Is -5, right? So we can see here we have -12 divided by 5. So that's our tan theta. Okay. So for 6.1.2, they ask us to determine or calculate the value of cos theta. So for us to find the value for cos theta, we need to also know our hypotenuse. So in this case, we don't know our hypotenuse, but we know our x value and we know our y value. How can we find the hypotenuse? Okay, so the hypotenuse, we can find the hypotenuse by using the theorem of Pythagoras. Okay, so our r squared will equals to x squared plus y squared. Okay, so what is our x squared? Our x squared is -5. So it's -5 squared plus y is what? Is 12. So we need to square it as well. Okay. So 5 squared is what? Is 25. And 12 squared is 144. Okay. And then when we add this, you get 169. Okay. Equals to r squared. And then your final value is supposed to give you 13. Okay, square root of 169 supposed to have 13. So 13 is your value for R. Okay, since now we know R, we can calculate what? Our cos theta. So our cos theta will be what? Will be the adjacent, right? Adjacent over the hypotenuse. Okay, so what is our adjacent? Our adjacent is negative 5. So it will be negative 5 divided by our hypotenuse, which is what? Which is 13, right? So that's our cos theta. Okay, so keeping that in mind, okay, let me write our cos theta also here because it will be important for us to use it on the next question. Okay, so okay, moving forward to 6.1.3. Okay, so for 6.1.3, we are told that there's a new point which is S, right? It has coordinates of A and B. So it's a point in the third quadrant, right? So it means that we'll have a point in the third quadrant. So let's draw a point here at the third quadrant. But before we draw a point, we are told that T O S is equals to theta plus 90. So theta plus 90. So it means this point here at the third quadrant here, the angle between O here and S here has to be what? 90. And when you add the theta here, it will be theta plus 90. So let's add uh, the point. Let's put a point here of S. Okay, because we are told that the new point on the third quadrant is S. So let's put S here. This is S. So we are told the coordinates of S. We have what? We have A and B. A and B. Okay. So we are also told that these here has to form a 90 degrees, right? Such that when you add um, the angles here for T angle OS, it will be theta plus 90 here. So that's the total angles here. Okay. So okay, so they asked us to what, and they gave us the value for OS. So OS is this one here, which is 6.5. So it's 6.5. Okay, we're told that this is 6.5 units. So, okay, they asked us to determine the value of B. So the first thing that we need to do here, we need to draw a line that connects with the x axis. Always you draw a line if you are given a point, because this is a point here, point S. So we need to draw a line, right, that connects with the x axis, right? So we have done that. So what we need to do, we need to establish, because our x value here is what is A. So this will be A here. This will be A, and then this will be B. Our B value will be our Y, so our B is here, and then our R is it's here, which is 6.5. Okay. Now we can calculate the value of B, right? So for us to find the value of B, we need to take note. We have the hypotenuse here, because if you look at this angle here, the angle here that we drawn at the third quadrant here. So we have what? We have B as the, okay, so this will be the angle here. So B is the opposite side. So this is the opposite side. And then this is the hypotenuse. And then this is the adjacent. So we need to calculate the value of B, right? We need to calculate the value of B. How do we calculate the value of B? Okay, so for opposite, B is our opposite. So we have sine. Okay, our sine, remember our theta now we add our 90. So it will be theta plus 90 degrees. So theta plus 90 degrees. So our opposite is B, right? This is B. And then our hypotenuse we are given, which is 6.5. Okay. So we need to take note that this sine theta plus 90, this is a co-function of cos, right? It's co-function of cos. So our cos will be what? Positive, because why? Because this sine is on the second quadrant. So this will be what? Will be the same as cos what? Cos theta. So cos theta will equal to b uh, divided by 6.5. Okay. So, but we know the value of cos theta because we calculated the value of cos theta on the second question, which is what? Which is this one here. Okay, so cos theta will equal to -5 divided by 13. So this will equal to b divided by 6.5. Okay. Uh, Now we can just cross multiply. So we can multiply b and 13. We'll have 13 multiplied by b. And then we multiply these two, 6.5 and -5. Okay. And then what do we have? We have b equals to 5, -5 times 6.5 divided by 13. Okay. So now we can use our calculator to confirm. So we'll have -5 times 6.5 divided by 13. Okay, so it means that our B is what? Our B is -2.5. So it makes sense because B here on the third quadrant it's also negative. So we should have a negative value. Okay. We have come to the end of today's session. Please don't forget to like and subscribe, and I'll see you on the next video. Thank you.